again to another video of making math easy for better understanding. Still, this is your teacher Hazel, and for today's video, we will tackle about partial fraction decomposition, non-repeating quadratic factors.
First, let us discuss what is a quadratic equation since our topic is about non-repeating quadratic factors. So, a quadratic equation is an algebraic expression of the second degree x. Its standard form is ax squared plus bx plus c equals 0, wherein a, b, and c are the coefficient, x is a variable, and c is the constant. And now, what is non-repeating quadratic factors or irreducible quadratic? So, an irreducible quadratic factor is a quadratic factor in the factorization of a polynomial that cannot be factored any further over the real numbers. So, how would we know that it is a non-repeating quadratic factor? So, if a quadratic factor ax squared plus bx plus c occurs once as a factor of the denominator of the given fraction, then corresponding to this factor associate a partial fraction. So, ax plus b over ax squared plus bx plus c, wherein a and b are the constant which are not both 0. Let us note that it is assumed that ax squared plus bx plus c cannot be factored into two real linear factors with integer coefficients. So here we have two examples for that. So the first example is x plus 4 all over x cubed minus 2x. So we could factor out the denominator into x times the quantity of x squared minus 2. So we could equate this equation to its partial fraction as a over x plus bx plus c all over x squared minus 2. Then the second equation is x all over the quantity of x squared plus 1 times the quantity of x squared plus 2. As you can see, we cannot factor out both of the factors. So we will automatically equate this to ax plus b all over x squared plus 1 plus cx plus d all over x squared plus 2. And now, let us solve for the first example. So the first example is x plus 4 all over the quantity of x cubed minus 2x. So on the previous line, we have it factored out to x times x squared minus 2. So as you can see, the first factor is a linear factor, and then the second factor is a quadratic factor. That is why the first factor, partial factor, is a over x, as it is a linear factor. So we could equate this to a over x plus bx plus c over x squared minus 2, which is the quadratic factor. So to solve for a, b, and c, we will find the LCD of this equation and then multiply it to the equation. So the LCD would be x cubed minus 2x, or x times the quantity of x squared minus 2. So let us multiply the LCD to the numerator, then divide it to the denominator. So that would be x, the quantity of x plus 4, multiplied to x, then multiplied to x squared minus 2, all over x cubed minus 2x, equals a times the LCD over x So that would be a times x squared minus 2 all over x plus the quantity of bx plus c times x times the quantity of x squared minus 2 all over x squared minus 2. So let us cancel out common terms in the denominator and the numerator, and then that leaves then that leaves us with x plus 4 equals a times the quantity of x squared minus 2 plus the quantity of bx plus c times x. And then let us distribute a to x squared minus 2 and then x to bx plus c. So that gives us x plus 4 equals ax squared minus 2a or a2. That would be just the same. Then bx squared plus cx. And then combine like terms. So that gives us x plus 4. Let us just copy the terms on the left side of the equation. So that would be x plus 4 equals ax squared plus bx squared plus cx minus 2a. And then factor out ax squared plus bx squared. So that would be x plus 4 equals x squared times the quantity of x plus b plus cx minus 2a. So as you could observe, on our left side of the equation, we have a linear terms or linear equation. However, on the right side, we have a quadratic equation. So that gives us that the coefficient on the right side, or the coefficient of the quadratic term on the right side, would be equated to 0. And then the linear term or the linear coefficient on the right side of the equation would be equated also to the coefficient of the linear term on the left side. So that would be c equals 1, and that same goes with the constant. So we have negative 2a over equals 4. Since we already have our values for c, we could use this third equation, which is negative 2a equals 4, to find the value of a. So just divide both sides by negative 2. So 4 divided by negative 2, that would be a equals negative 2. And then since we already have our value for a, let us substitute this value to the first equation to find the value of b. So negative 2 plus b equals 0. So using additive inverse property, move negative 2 to the right side. That would be b equals 2. So now we have our values for a, b, and c. We can now get our partial fraction for the equation x plus 4 over x cubed minus 2x. So the value of a, just substitute the values for a, b, and c. That gives us negative 2 over x plus 2x plus 1 all over x squared plus minus 2. And now here is our second example, which is x all over the quantity of x squared plus 1 multiplied to the quantity of x squared plus 2. So as you can see, we have both factors as quadratics, wherein the highest degree is 2. So we would equate these two ax plus b all over x squared plus 1 plus cx plus b all over the second factor x squared plus 2. So since both of the equation is quadratic, so let us find the LCD to find the values of a, b, and b, c, and d. So the LCD would be x squared plus 1 times the quantity of x squared plus 2. Let us multiply this LCD to the numerator and divide it to the denominator. So that gives us x equals the quantity of ax plus b times x squared plus 2 plus cx plus d multiplied 2x squared plus 1. So let us use long method. Multiply ax plus b times the quantity of x squared plus 2. same goes with cx plus d multiplied to x squared plus 1. So that gives us ax cubed plus ax 2 plus bx squared plus 2b plus cx cubed. So multiply also this one. So that gives us cx cubed plus cx plus dx squared plus b. And then combine like terms, we have ax squared plus bx squared. And no, that would be cx cubed. So that must be ax cubed plus cx cubed plus bx squared plus dx squared plus ax2 plus cx plus b. And then let us factor out ax cubed plus cx cubed. That would be c cubed times the quantity of x, a plus c, plus factor out also bx squared plus dx squared. That would be x squared times the quantity of b plus d. Then ax squared. Oh no, that is not ax squared. That would be x times 2a plus c plus d. So as you can see, we only have linear term on our left side of the equation, and then on the right side we have a cubic equation. So that means that the other coefficient would be equated to 0 except for the linear term. So that gives us a plus c equals 0, which is the coefficient of the cubic term. Then b plus d, which is the coefficient of the quadratic term, equals 0. Then the linear term, 2a plus c equals 1. Then d equals 0. So since we already have our value for d, let us substitute this value to the second equation to find the value of b. So that gives us b plus 0 equals 0. So b plus 0 is b, so we have our value for b, which is 0. And now let us copy both the equation, the third equation, and the first equation. So let us copy 2a plus c equals 1. C equals 1, and then the first equation, a plus c equals 0. So we could find the values for a and c using elimination method. In here, let us eliminate c, and then minus 2a minus a, that would be a. So 1 minus 0 would be 1. So now we have our value for a. Let us substitute this value the first equation, which is a plus c. So that would be a plus 1 plus c equals 0. So move 1 to the right side using additive inverse property. We have c equals negative 1. So since we already have our values for a to d, we could now solve for the partial fraction of x all over the quantity of x squared plus 1 multiplied to x squared plus 2. So let us just substitute the values for a, b, c, and d. So that gives us x plus 0 all over x squared plus 1 plus negative x plus 0 over x squared plus 2. Then finding the lowest term, we have x over, or the final term, we have x over x squared plus 1 plus negative x plus x squared plus 2. So that's now your answer.
And that's all. I hope that you've learned something for today's video, and don't forget to like, comment, and share, and hit the notification bell for more updates.